Hello everybody, how's everybody doing? CRS here. In this video, we will be discussing about how horizontal projection has to be dealt with and a few important points. We will be solving an easy question to begin with, and then we will look at a question that was asked in one of the previous year IITs. So let's begin with the most important points about horizontal projection. When you have an object that is being projected with a certain velocity from an elevation, let's say you are standing on a building, and from the building you are projecting an object with an initial velocity u. Now when that is the case, the object is obviously going to fall off like that. Now this is what is called the range, and the amount of time that is there, that the projectile is there in the air, that's time of flight. Of course, if you have projected it exactly horizontally, then the maximum height is just this, right? All of these points you need to understand it a little well, because the equations that you derived for a regular projectile r is u square sine 2 theta divided by g for range, h is u square sine square theta divided by 2g for maximum height. All of these equations that you learned won't work for this case, because these equations were derived for ground to ground projection. That means you shoot an object from the ground, it falls back to the ground. If it does not, then these equations are worthless. You need to learn to deal with projections that are not ground to ground projections. So that's why this video. Let's learn it in detail about how to go ahead with problems like these. Dear friends, if you want to talk about the velocities, obviously here there is only an initial velocity that is given in that direction. The initial velocity in the y direction is 0. So the particle, when was projected horizontally, does not have a vertical velocity, but because the acceleration due to gravity is acting on it, the particle goes on increasing its velocity in the downward direction as and when it falls down. But what you need to understand is the horizontal velocity always remains the same. It was u while throwing it, it was u midway, it is u right before it stops, right before it falls to the ground, and every point in its journey, it's just u, right? The reason being there is no acceleration in that direction. This is the most important part, and rest everything will be dealt with equations of kinematics that are going to be applied for two different axes, the y-axis and the x-axis. Namely, you can write all the three equations: s is equal to ut plus half at square, v equal to u plus at, and v square equal to u square plus 2as. But you need to apply the right sign convention and get to the answer. You can apply these equations of kinematics for both the axes of the coordinate system. So let's start solving problems based on horizontal projection and projection at an angle from an elevation. So such problems are quite common in competitive exams like JEE, Neet and CET. So let's look at this. The first question, relatively an easier question. I'll go slow, follow. In case you find this too slow, you can speed the video up. A ball is thrown from the top of a building 45-meter high. So let me imagine a building that's 45-meter high, dear friends. That's the building. And let me also draw the floor. The floor is here. That's the floor. Okay. And then from the top of a building 45-meter high, let me say that this is 45. That's 45 meter with a speed of 20 meter per second. From the top of this tower, an object is projected like this. So let's think that that's the initial velocity vector. I'll just name that u, right? I'll just name that u. Initial velocity has been given to us. U, dear friends, is 20 meter per second. 20 meter per second it is. Okay. At an angle of 30 degree. So we have also been given that angle, that's 30 degree. Okay. Find the time taken by the ball to reach the ground. So the ball is going to reach the ground nonetheless. It's going to take a trajectory like this. Okay. It's going to take a trajectory something like this. It's going to fall to the ground. What are the things that we need to find? Time taken by the ball to reach the ground. How long does it take for it to reach the ground? From when it's projected like that, falls to the ground, how long does the ball take to reach the ground? That's the question. Let's answer that question first. Dear friends, let's assume first thing that you need to do is find proper sign convention. For that, you will have to get your origin. And once you have the origin, you can decide the directions of coordinate axis. Let's begin with that. Let's assume that this side, the right side, is positive x axis, and in the upward direction is positive y axis. All the vectors that we are going to write, namely displacement, acceleration, and initial velocity, final velocity, all of these vectors will be written according to these coordinate axes. So if there is a vector looking in the positive x, we will write that number positive. If there is a number, if there is a velocity that is in the negative x direction, we will write that number negative. So depending on the direction of that vector, you will be able to write down the sign convention to get to the answer. That's how you solve it. Let's do this one now. I would like to find out what is the time it takes to fall to the ground. Let me just apply an equation for y-axis. I'll just write for y-axis. Okay. The initial velocity of the body along the y-axis is u sine 30. That side it would be u cos 30. This side it would be u sine 30. Because it is in the upward direction is positive y, I shall write plus 20 sine 30. Okay, which is certainly going to be 10 meter per second. That's how fast it's going up. Great. And what is its displacement? Don't you think the initial position of the ball is here and it's going to fall down to the ground? It's going down. If it's going down, displacement is in the downward direction, which means displacement along the y-axis is negative. And how much does it fall down? It falls down to a height of to a depth of 45 meter if you're standing at the top. So it's minus 45 meter, dear friends. That's the displacement along the y-axis. Now, you also need to find out what is the acceleration along the y-axis. Acceleration along the y-axis is just acceleration due to gravity. It's pulling it down. If it's pulling it down, it's pulling it down with, let's say, an acceleration of 10 meter per second square. It is easier for me to write 10. It is 9.81 meter per second square, but for simplicity, I've just taken it 10. Anyway, with this information, we should be able to solve for the amount of time it takes for it to reach the ground. Let's write the equation. The equation is Sy equal to Uy into T plus half Ay into T square. That's the equation you have. Let us substitute all of this. We have Sy equal to minus 45 equal to Uy is plus 10 into T minus half into 10 multiplied by T square. So you have the equation. I have just substituted minus 10. Minus into plus becomes minus. Instead of putting it there, I've written it here. Let us simplify this. Maybe you can transfer all the terms to this side. You will get 5t square, right, minus 10t minus 45 would be equal to 0. Let's divide the whole equation with 5. We will have t square minus 2t minus 9 would become equal to 0. You just have to solve this quadratic equation. If you solve this quadratic equation, what do you get? The time t would become minus b plus or minus root of b square minus of minus would become plus 4ac divided by 2a. A is 1. So we have the equation. 2 plus or minus root 40 can be written as 2 root 10 divided by 2. Obviously, there are two roots. 2 plus root 2, 2 root 10 divided by 2, which is going to be 1 plus or minus root 10, right? You cannot take negative there. You cannot be taking the minus sign there because it is impossible for time to be negative. So the correct answer for the time is simply 1 plus root 10 seconds, my friends. This is how much time it takes for the projectile to fall to the ground. And we've answered the first question. Answering the second part of the question, the speed of the ball just before it touches the ground. What is the speed of the ball just before it touches the ground? For that, we will have to think what are the initial velocities. I just told you that the initial velocities can be drawn like this. The initial velocity along the x-axis is u cos theta, and initial velocity along the y-axis is u sin theta. We have also used u sin theta in this equation, right? We need to know Vx, which is final velocity along the x-axis, and Ux, which is the final velocity along the y-axis, Uy, final velocity along the y-axis, in order to find the total velocity of the projectile before it strikes the ground. When that is the case, let us figure out what is u sin theta. I mean, the final velocity along the x direction, dear friends, is simply initial velocity along the x direction, because there is no acceleration along that direction. And how much is that? Ux is 20 cos 30. Cos 30, dear friends, is root 3 by 2. So the answer you would have is 10 root 3 meter per second. That's the answer you will have. Velocity along the x direction, which is going to be directed this way. Maybe I'll just use a different color to show you that the velocity along x would be in this direction, and velocity along y would be in this direction. Resultant velocity will be in this direction, right? So that's the resultant velocity. Similarly, we shall now write down what would be the final velocity along the y direction. I would like to use v square is equal to u square plus 2as all along the y axis, because we have taken care of the x direction already. So vy square is equal to uy square plus 2ay into sy. Vy square has to be figured out. Let's do that. It's equal to uy square. Is there an initial velocity in the downward direction? No, but it is there in the upward direction. How much is that? U sin theta. U, dear friends, is 20. Sin 30 it is going to be, which is 10. You have 10 square plus 2 into both ay is minus 10 and sy is minus 45. Minus into minus will become plus. So this is going to be 450, right? 45 multiplied by 10 would be 450. So what do you have at the end? Vy square, dear friends, would become equal to 100 here plus a 900 here, which is 1000 meters square per second square, because this is Vy square. Okay. And how do you find the total velocity? The total velocity can now be found like this. The total velocity V would simply be equal to root of Vx square plus Vy square. That is the total velocity. Vx square, dear friends, is 10 root 3 the whole square, which is going to be 300, plus Vy square. It's already there. We have 1000. The answer is root of 1300. Root of 1300 is dear friends, is going to be 10 root 13 meter per second. This is the final answer for the velocity with which it strikes the ground. Well, this is the complete solution for the problem which asks you to find the speed of the ball before it hits the ground, and we have solved both the questions. You need to analyze this question and try to solve as many problems as possible. Write to me if you need a worksheet on this, and I'll definitely give you a worksheet, but practice questions on projection that's not from ground to ground. It's a very important topic. Let us go further and solve a problem which was asked in one of the IIT exams. Let's look at what the question is. Two towers AB and CD are situated at a distance d apart as shown in figure. AB is 20 meter high. Let me just write down that this is 20 meter high. That's AB. And CD is 30 meter high. CD is, dear friends, 30 meter high from the ground. An object of mass m is thrown from the top of AB horizontally. Top of AB horizontally, it's thrown like that. So this projectile does not have a vertical velocity. I'll just call that particle A, okay, because it's being thrown from A. It does not have an initial velocity in the y direction. Let's look at what the other question says. But the question very clearly says the velocity is 10 meter per second. This is also 10 meter per second if you read further. Towards CD. Simultaneously, another object of mass 2m. So the masses are different. this is M and that's 2M, are thrown from the top of CD at an angle of 60 degree, quite visible in the question, towards AB with the same magnitude of initial velocity. That means that's also 10 meter per second. The two objects move in the same vertical plane, so they don't come out of the board, they are on the board. The two objects move in the same vertical direction, collide in mid-air. So both of these sort of collide and then move in the same vertical plane, collide and stick to each other. So what sort of a collision is this? This is a perfectly inelastic collision. Perfectly inelastic collision, wherein the two bodies stick to one another and they fall down. The questions here are: calculate the distance between the two towers. We have to find D. Let's do that first. Okay. I'll just write down equations along the y direction. Okay. Let's write down equations along the y direction for y axis. These questions of IIT must be not only be solved quickly, but then they have to be solved absolutely accurately. So conceptual clarity plays a very, very important role. Work on that. Let's begin solving this question. Dear friends, I am going to solve this question using the concept of relative velocity, and I am just applying relative velocity with respect to one particle along one axis, which I've covered in another video. Relative velocity in one dimension. That video should help you. If you did not get that right, go to that video and then solve questions there. Come back here, you will be able to understand this even better. Let's go further. The velocity of C, particle C, because it's being projected, as seen by A in the y direction is all that I'm writing. That's going to be Vc minus Va. But Va, dear friends, isn't moving. Va is velocity of A. It's not moving along the y-axis. So Va is 0. Vc is the velocity of particle C in the downward direction. Don't you think the velocity of the particle in the downward direction is the sine component of 10 meter per second? Because 60 degree is the angle that it makes with the x direction. The theta sticks to x-axis. So the y-axis will have the sine component of the vector. Okay. So this is 10 sine 60 degree, which is going to be 5 root 3 meter per second. That's the velocity of C as seen by A in the downward direction. Because it is downward, dear friends, because it is downward, I shall put a minus sign to this, because Vc, dear friends, is in the downward direction. I shall put a minus sign here. Vc is negative. I have put that. Va is 0, so I have not bothered to write it. Minus 5 root 3 meter per second. What is the acceleration of C as seen by A? Both of them are under free fall. So both of them have the same acceleration. This is G this is minus G, that is minus of minus plus G. Both of them will get cancelled. The acceleration relative to A, the acceleration of C relative to A would be 0. As simple as that. We will also look at the displacement of C as seen by A. Displacement of C as seen by A is in the downward direction. If you were particle A, then you will be going down, but the other particle will also come and it collides with you. That means you will see that particle coming towards you, down, coming towards you, meaning because that's higher, it is going to come down. The displacement is negative. You can just write minus 10 meter, right? Because initially you are separated by a distance of 10 meter. This is 20, that is 30, and distance between you is 10 meter. And by the time you go here, that also comes and collides with you. Total distance has reduced to 0. The total distance traveled by C as seen by A would be 10 meter in the downward direction. That's why I have written this. Anyway, going further, we will be able to now find the time at which the two projectiles collide. Let's do this. SCA equal to UCA. Of course, this can also be said that it's the velocity, initial velocity. It's not a final velocity. Maybe I'll just change all of this to U. It does not make a lot of difference though. Okay. All of that is U. UCA minus, UC minus UA. And, okay, that's fine. This is also UCA. Fine. SCA is equal to UCA into T plus half ACA into T square. But we know that ACA is 0. That means this term goes to 0. what is the time you will have? SCA, dear friends, is minus 10 meter. It's equal to, maybe it's just minus 10, not right meter there. And here it is minus 5 root 3 into T. Minus signs go away. 5 ones are 5 twos are. T would become equal to 2 divided by root 3 second. That's the time at which both of these projectiles will collide with one another, because they are at the same horizontal level. Okay. This is going faster than that. Only when they are at the same horizontal level is there a possibility of collision, and that's why the time at which they would collide is t equal to 2 by root 3 second. Having said that, we will now be finding what is the distance that the particle A travels in the horizontal direction in this time. The horizontal distance traveled by particle A in that direction would be simply equal to horizontal velocity of A. I'll just write it as UAX into T, because there is no acceleration in that direction. Displacement would be equal to velocity into time. Displacement of A, dear friends, in that direction is initial velocity is 10. It's in horizontal. That does not change. So it's just 10 multiplied by T, which is 2 divided by root 3. Okay. That's XA. Maybe both of them meet somewhere here. So XA would be the distance from the wall, from the tower to the point where they meet. Okay, they would come and meet like that, right? XA is this, and similarly, what is XB? XB is the distance that particle, not XB, XC, sorry, XC. What is XC? XC is the distance that particle C travels from the second tower to the point of collision. Let me call that XC. Okay. XC is also initial velocity of C along the x direction into T. Of course, it is negative. Both the displacement as well as the initial velocity in the x direction are negative. The negative signs would get cancelled out. So I haven't bothered to write it. Initial velocity along the x direction, dear friends, is 10 cos 60 degree. Cos 60, dear friends, is 1 by 2. So it would simply be 5 into T, 2 divided by root 3. Okay. Don't you think XA plus XC is the distance between them? Distance between them is XA plus XC. Then the distance between them becomes XA, dear friends, 20 divided by root 3 plus XC is 10 divided by root 3, makes it 30 divided by root 3, which is certainly equal to 10 root 3 meter. This is the answer for the distance between the two towers. So this question could look in the first glance to be completely irrelated to the given data, but you can get the answer for these questions. That's the beauty of it. Going further, find the position where the objects hit the ground. Where do these objects hit the ground? That's the question. For answering that question, after they hit one another, they stick. My question to you is, what is the direction of velocity and what is the velocity of the combined mass? So there is m coming from this side, there's 2m coming from that side, both of them hit one another. What is the combined velocity is the question. Let us try and understand this. Dear friends, I'll apply conservation of linear momentum, that is positive x direction. So mass of the object into velocity of the object. The first mass is m and its velocity is 10. It's positive because that velocity is in the positive x direction. Plus the mass of the second body, dear friends, is 2m. I shall write 2m multiplied by the velocity. Initial velocity in the horizontal direction is v cos 60 degrees. How much is v cos 60 degree? V cos 60, dear friends, is certainly v into 1 by 2. So 10 into, let's say, 5. 10 into 0.5 is going to be 5. Cos 30 degree. Cos 60 degree. Cos 60 is 1 by 2. That's how I get that. But this is a negative velocity. It's going in that direction. The total momentum would be the final momentum after they collide. That would be the total momentum after they collide. So what is the final momentum, dear friends? The final momentum is 10m, 2 into 5 minus 10m. The answer is 0. The final momentum is 0. So both the masses after they collide do not have any momentum. Mass is definitely non-zero. The velocity must be zero. So they are going straight down. So they are going, they come like that. One mass is coming from a higher place, the other one is being shot horizontally, and they collide. When they collide, they have the total momentum equal to zero. So they are not going to have a horizontal velocity anymore, because this equation is for conservation of linear momentum along the horizontal. I can apply it because there is no force in that direction. Hence, they do not have any velocity along the horizontal. They will start dropping straight down. So they will drop down straight like that. Okay. And what is that distance XA? XA is the distance, and XA, dear friends, is 10 into 2 divided by root 3. The distance at which both of these projectiles fall to the ground is XA. It's equal to 20 divided by root 3 meter, dear friends. And that's the answer to the second part of the question. We've answered both. Distance between them is D, and the position where the projectiles, after sticking to one another, fall down to the ground is 20 by root 3 meter. So that was a problem, takes a little bit of thought, but definitely can be solved in a short time if you understand the concepts of relative velocity. That's all I have for this session. I will come back with another video. Thank you so much.